Hello students, how are you all? I hope all of you are doing very well. This is my channel Simma Academy, and today I'll be taking a session on chemical bonding. Okay, this is about how metals and non-metals react. Okay, this is a small part of the grade 10 chemistry. Okay, the metals and the non-metals topic. So if you have not subscribed to my channel, for more videos, please go and subscribe to my channel. I'll be coming up with more videos which will be helpful for your exam preparations. So starting with this topic, that is metals and non-metals, how do they react? Okay, so metals and non-metals, grade 10 students, you must have started with the chapter, you must have completed also for your board exams. So the main problem, some of the topics are there which children find it difficult to understand, how the metals and the non-metals are reacting. Okay, so how the chemical combination takes place. So I thought I'll just take a small session on that. So this is about that. Okay, so before starting with the actual chemical combination part, so we have to understand what is a chemical bond. So what is a chemical bond? So what is a chemical bond? It is nothing but the force which binds the atoms. Okay, now atoms can be a single atom, two atoms together, or more atoms together. Okay, in a stable molecule. Okay, so when the atoms combine, 2 atoms combine, 3 atoms combine, 4 atoms combine, they have to combine in such a way in order to become stable. And the molecule, when they form, that atoms combine to form molecules. Okay, so when the molecule they form, the molecule has to be in the stable state. Okay, that is the main purpose of showing the chemical bond. Okay, or forming the chemical bond in a molecule. Okay, so what is an atom? Children, I hope you have studied atomic structure or atoms and molecules in grade 9. So what is an atom? I'll just quickly tell you. So atom consists of the core, which is made up of protons and neutrons. Okay, this is the nucleus. Okay, and around it there are discrete orbits in which we have electrons, okay, in different energy levels. So we have K, L, M, N shells. Protons are positively charged, neutrons are neutral, no charge, okay, and electrons are having negative charge. Okay, so you know that atom as a whole is neutral. So the types of elements which are involved in a chemical combination, we have metals, okay, and we have non-metals. Okay, now metals will have 1, 2 or 3 electrons in the outermost shell. The outermost shell is called as the valence shell. Okay, suppose example lithium. Lithium atomic number is 3, so electronic configuration is 2, 1. Okay, so here outermost shell is having 1 electron. Okay, so this is a metal. Non-metals have 4, 5, 6, 7 electrons. Okay, 4 we will not consider, that comes in another bond formation. So if the elements are having 5, 6 or 7 electrons in the valence shell, okay, we call them as non-metals. Example, you can take chlorine. Chlorine atomic number 17, electronic configuration 287. Okay, so here it is having 7 electrons in the valence shell, so this is non-metal. So the topic which we are doing today is the reaction between the metals and the non-metals. What is the bond formation happening between metals and non-metals to form a compound? Okay, how metals and non-metals react to form a stable compound. Okay, so here what you see is the metals having 1, 2, 3 electrons. Okay, they always lose electrons and they form cations. Okay, whereas the non-metals, they always gain electron and they become anions. That means anions are negatively charged, they attain a negative charge. Okay, and when metals lose electron, they become cation, they attain positive charge. Okay, this you should understand. Okay, there are two charged particles. We form ions. Once the metals lose electron, it forms a positively charged ion. They are the charged particles. And here they form an ion, negatively charged ion. Okay. Now the method which is used in the formation of the compound by a metal and a non-metal. Okay, the method we are using is, here it will be transfer of electrons. Okay, transfer of electrons from metal to non-metal. Okay, to form ionic bond, or it is also called as electrovalent bond. Now, who is losing? So here metals lose electrons, metal will lose electrons, and non-metals will gain electron. Okay, now why they lose electron, why they gain electron? In order to attain stable noble gas configuration. Okay, now what are noble gases? Now what are noble gases? So noble gases are the inert or unreactive elements. Okay, they are mostly gases, like we have helium, we have neon, we have argon. This is helium. I'm writing the symbol. This is neon. This is argon. Okay, atomic number 2, atomic number 10, argon atomic number 18. So its EC is, electronic configuration is 2. Here it is 2,8. Argon is having 2,8,8. Okay, so the noble gases are inert, unreactive elements. Because why they are so? Because they have filled valence shell. They are complete valence shell. Okay, so K shell is having maximum holding capacity of 2 electrons. So helium is having valence shell complete. Its valence shell is only K shell, okay, which is completely filled with 2 electrons. So this is called as duplet. Okay, it is having duplet configuration. Similarly, neon is having 8 electrons. So K shell, L shell. L shell is having maximum capacity of 8 electrons. So it is filled with 8 electrons. This is having octet configuration. Okay, similarly argon also having KLM. The last shell is having filled with 8 electrons, which is also having octet configuration. Okay, so these noble gases, they have complete outermost shell electrons and they are considered as stable, because when they are stable, when they are having the completely filled outermost shell, they are in the low energy state. Low energy state. See, nature follows, nature says that everything should be in the low energy state, like your example, a ball rolling down a hill, okay, or the water flowing down. So it is always, everything wants to come to a low energy state, which is considered as a stable state. So noble gases, since their outermost electron is shell is completed, they don't have to gain electron nor they have to lose electron. Okay, so they are stable, they don't react with anything. Okay, so the elements now, so the metals, now if I say metals don't have outermost shell complete, like I gave you example 2, 1. So the outermost shell is having only 1 electron. It is not completely filled with 8 electrons, right? Similarly, non-metals also, non-metal example I gave you chlorine, right? Chlorine 2, 8, 7. Now here also the last shell is having 1 electron less in order to have a octet configuration. So the metals and the non-metals, in order to gain stability, in order to come to a lower energy state, they have to either lose electron or gain electron. So metals will lose electron and non-metals will gain electron in order to become stable. Okay, that is a main reason for chemical combination. That's why the atoms of different elements, they come together, they combine in order to attain stability of the nearest noble gas and form a chemical compound. So let's see an example of formation of NaCl. Now NaCl is a compound formed by the metal. Here is the sodium, okay, and non-metal, here is chlorine. Okay, its electronic configuration is 281, atomic number is 11, right? And its chlorine is atomic number 17, 287. Now you see here, sodium is having only 1 electron in the valence shell. Here chlorine is having 7 electrons in the valence shell. So what here happens is, metals, as I said, they will lose electron. Okay, now sodium will lose electron and becomes a anion. How many electrons it loses? It loses this 1 electron. That's why I am putting 1 charge, plus 1 charge. Okay, it is lost this 1 electron and it becomes a cation. Okay, whereas if you see non-metal, chlorine here, it will gain electron. Okay, so chlorine will gain 1 electron because it requires 1 to complete its octet. Here it requires, sodium requires to lose this 1 electron in order to get a nearest. Here which configuration it will get? It will get nearest neon configuration, that is 28. Okay, 28. So here if you see, now here chlorine is gaining 1 electron in order to become, here it will get negative charge. Okay, in order to become, it will get a what configuration? It will become, now sodium plus had configuration 28. Now chlorine will get configuration of 288, which is argon configuration, 288. Okay, so that's how they attain stability. So that's how the bond is formed between two oppositely charged ions. So how bond is formed? Now sodium 1 plus, chlorine 1 negative, right? So here oppositely charged ions, they are oppositely charged ions, they attract each other and they form a bond and a compound called sodium chloride. Okay, so criss-cross method of writing the formula you must have learned in grade 9 also. So here criss-cross method, if you have learned, right? So you used to write criss-cross, Na will get 1 and number 1 here, so NaCl formula. So last year you have studied the criss-cross method of writing the formulas. So here, but actually the bond formation takes place by loss of electron by the metals and gain of electrons by the non-metals. Okay, this is how chemical bonding takes place. So children, you might be having a doubt that why metals have to always lose electron and why non-metals have to always gain electron. Okay, so I'll just give you a little bit clarification on that. See, you have to understand, what is IP, that is ionization potential. You have to also understand what is electron affinity. Okay, so what is ionization potential? Ionization potential is the energy required to remove an electron, from atom. So why metals? Metals will have very low IP. Okay, metals have very low IP because the amount of energy required to remove the outermost shell electron is very, very low. It is able to remove the electron. Why? Because the atomic radius is high. Okay, atomic radius means distance from the center of the nucleus till the outermost shell. So since the atomic radius is very high, the outermost, the electron, the pull of the outermost electron to the nucleus is less. So that's why the amount of energy which you need to supply to this atom to remove the outermost electron is very, very low. That's why they easily lose the electrons to become cations. Okay. Now if you want to know what is electron affinity, now electron affinity means is love for the electrons. Okay, how much it likes the electron. Okay, so electron affinity for non-metals, so this is the how we define is energy released when an atom accepts an electron. Okay, so why energy has to release when an atom accepts an electron? Because when the atom is accepting an electron, the electron is coming to a lower energy state. So lower energy state is a more stable state. I told you, when it comes to the lower energy state, the extra energy has to get released from the atom. Okay, that's why the energy released when an atom is accepting an electron. So for non-metals, you know, for non-metals, EA is very, very high. That means, and also, you know, atomic radius is small. So when the atomic radius is small, if this is smaller, so the outermost electrons pull towards the nucleus is very, very strong. Okay, and it is very difficult to remove an electron from the outermost shell. But instead, since the electron affinity is very high, the love for electron is very, very high, they are able to easily accept the electron. And moreover, suppose it took the example of chlorine 287, it is able to easily accept one electron because energy released will be less, not much energy they release, and they can form a stable nearest noble gas configuration. But in order to remove this 7 electron, very high amount of energy needs to be supplied, okay, which is not thermodynamically stable state. Okay, that's the reason non-metals always gain electrons and metals always lose electrons. Okay, so this is a very brief concept which I gave you to understand the idea behind the reaction of a metal and a non-metal. So I hope this is helpful for you to understand the bond formation between a metal and a non-metal. So if you like this video, please subscribe to my channel. I'll be coming up with more videos. Till then, take care and I'll see you soon. Bye-bye.